Hi everyone, this is Dr. Nak, and we're going to go over section 8.3, more radicals, but simplify rational exponents. And what the heck is the rational exponents? Well, rational, think of it as in fractions. So what we're going to be dealing with is the fractional exponents in this section. Now, the rational exponents are another way of writing expression with radicals. And when we use rational exponents or fractional exponents, we can apply the properties of exponents to simplify the given expressions. So let's first go with the definition of a rational exponent, a to the 1 over n. It says that if nth root of a is a real number and n is greater or equal to 2, then a to the 1 over n is precisely nth root of a. So basically, the denominator of the fractional exponent becomes the index of the radical. Let's do some examples. Example 1, write as a radical expression. So let's do a few examples of this. So part A, x to the 1/2. So what we want to do is we want to convert this in terms of a radical notation. So let's do it. Now remember, the denominator, which is the bottom, becomes the root. So in this case, our index is going to be 2, which gives us the square root. So here what we're going to get is, this means that square root of x. Well, we don't write that square, so our answer is just square root of x. Now let's do y to the 1/4. So the bottom of the fraction becomes the root, so what we're talking about is the 4th root. So in this case, what we're going to get is 4th root of y. And that's it. So that's just going to be the answer. And of course, if you have something like, let's go with z to the 1/3. So the bottom becomes the root. So in this case, we're going to talking about the cube root of z. And that's that. Now let's take a look at example 2. Write with a rational exponent. So basically we're going to be working backwards now. So given square root of 7y, we want to convert that into a rational exponent, rational fraction, fractional exponent. So since we're given the square root, the power that what we're going to get is just 1/2. So here, we're going to have, don't forget to put the 7y in the parentheses because 7y is one quantity. So here what we're going to get is 7y to the 1/2. Now let's look at cube root of 6x. So we're talking about the cube root. So in terms of a rational exponent, our denominator of that rational exponent must be 3. So here we're going to have 6x. Make sure to put that in the parentheses, to the 1/3 power. The next one, 5 times 4th root of 7z. So I try to throw you off by putting the 5 on the front, but that does not matter because just leave the 5 alone. And what we need to do now is to translate the 4th root in terms of a fractional exponent or rational exponent. So here, what we're going to get is 7z, that's a z, I'm sorry, that's not a 2, so 7z. Now, since you're given the 4th root, what we're going to get here is going to be 1/4. So that's that. Now, please note that that 1/4 is attached on the whole quantity 7z, but not on the 5. So I'm just going to box that. So in general, if you want to simplify the expressions with maybe a to the m over n, what's going to happen is that a to the m over n, again, bottom is the root. So we're going to have nth root of a to the m. Now, which is equivalent to nth root of a, and then you raise that whole quantity to the mth power. Because on the previous example that what we did, our m numerator was 1, wasn't it? So for instance, if we had a to the, let's go with like maybe 1/3, what was that? Well, bottom becomes the root, so we're going to have a cube root of a. But a, same thing as a to the first now, isn't it? So that's why we had cube root of a. Let's take a look at example 2. Write with a rational exponent. So here, we are given square root of x to the 7. So what we want to do is we want to rewrite this radical by using the fractional exponent. So let's do this. Remember that square root, there is that invisible 2 sitting out here. So this is nothing but x to the, now remember, the index becomes the root. So that means that 2 must appear on the denominator of the fraction. So this is going to equal to 7 over 2. That's it. Now let's look at b. Cube root of 4x, whole thing, raise it to the 4th power. Do not panic. So let's apply the property. Now let's look at this property here. If we have nth root of a to the m, this is same thing as a to the m over n. So if we follow that, then what we're going to get is 4x in the parentheses and then 4 over 3. So that's going to be the answer. So basically you can think of it in this way. So if you have a to the m over n, this is how I used to memorize it. Top is the power, bottom is the root. So bottom, root grows towards the bottom, so bottom is the root, and top is the power, which is m. And then n is going to be the root. So here, if I think of it in that way, bottom is the root, so the bottom is n, so we are talking about nth root, and top is the power, meaning m is the power, so we're going to have a to the m, which is equivalent to nth root of a whole thing to the mth power. I know that this is very silly, but this is just how I memorized it when I was taking this class. I always remember that root grows on the bottom, so bottom is the root, and then top is the power. Yes, go ahead and laugh. I really don't care. So there. But anyways, let's take a look at another one. All right, let's look at square root of the quantity 3a over 5b to the 4th power. Okay, so what kind of root are we given? The root, we're given the square root. So what's going to happen here is 3a over 5b. And then remember, root is the bottom, so you're going to have 2 on the bottom, and then top is going to be the power. So in this case, it looks like what we're going to get is 3a over 5b to the 4 divided by 2 is 2. So in this case, okay, let's go one more step. So this is same thing as 3 squared times a squared, whole thing over 5 squared, and then b squared. That's one of the properties of the exponents. So this is going to be 9a squared all over 25b squared. And I'm just going to box that for the answer. Now let's look at the next property. Simplify expressions with a to the negative n, and then also 1 over a to the negative n. So it says that for any real number, which of course a cannot be 0, a to the negative n equals to 1 over a to the n. Also, 1 over a to the negative n equals a to the n. Let's do some examples. Example 3, simplify 16 to the negative 3 over 2. Okay, so now this guy has negative exponent, so what we need to do is you're going to pretty much flip, meaning take the reciprocal of 16, which is 1 over 16, then you're going to turn that negative exponent into a positive exponent. So what we're going to get is 1 over 16 to the positive 3 over 2. And if I keep simplifying this, here what we're going to get is 1 over, remember, the bottom is the root, so we're going to have the square root of 16, and then whole thing to the 3rd power. So, which is same thing as 1 over, well, square root of 16 is 4, so we're going to have 4 to the 3rd. So our answer is going to be 1 over 4 times 4 times 4 is 64, and that's going to be the answer. Don't worry, we're going to do another one. let's look at 32 to the negative 2 over 5. So again, 32 has a negative exponent on it. So what's going to happen is you take the reciprocal of 32, which is 1 over 32. Then you're going to have to attach the positive exponent on the 32. So this is same thing as 1 over, okay, what kind of root are we talking about? Bottom is the root, so we are talking about the fifth root of 32, and then whole thing squared. So if you cannot figure it out what the fifth root of 32 is, just break it down. So 2 times 16, 4, 4, and then 2, 2, 2, 2. Okay, so it looks like 32 is 2 to the, how many 2's do we have? 2 to the fifth. Awesome. So what we're going to get here now is 1 over fifth root of 2 to the fifth to the second power. Alright, so then our answer is going to be 1 over 2 squared. So what we're going to get is 1/4. Okay, now let's take a look at example 4. Simplify negative 81 to the 3 over 2. Okay, so first you need to ask yourself, where is that exponent 3 over 2 attached on? Well, it's only attached on the 81, not on the negative, so be careful. So when you simplify this, just ignore the negative sign. So basically what we're going to do is we're going to simplify 81 to the 3 over 2. So again, bottom is the root, so we're going to have a square root of 81 to the third power. So carry on the negative. So here what we're going to get is negative square root of 81 is what? 9. And then 9 to the third. Again, that exponent 3 is only attached on the 9, not on the negative. So what we need to do is multiply 9 3 times. So what is that? 9 times 9 times 9, 729. Alright, so our answer is going to be negative 729. Alright, now let's look at part B. Negative 81 to the negative 3/2. So again, that negative 3/2 is only attached on the 81, not on the negative that's in front of 81. So again, leave that negative alone. Now what we need to do is we need to rewrite 81 to the negative 3 over 2 in terms of a positive exponent. So what we need to do is you need to take the reciprocal of 81, which will be 1 over 81. Then you're going to attach the positive exponent on that 81. So let's keep simplifying. So this is same thing as 1 over square root of 81 to the third. So what do we get? Negative 1 over 9 to the third. So in this case, what we're going to get is negative 1 over 729. Okay, part C. Now let's take a look at whole quantity negative 81 to the negative 3 over 2. So please notice the difference between B and a C. That little tiny parentheses can change the whole entire problem. So in this case, our exponent negative 3/2 is attached on the whole entire negative 81 now. So here what we need to do is we take the reciprocal of negative 81, which will be 1 over negative 81. Then you're going to have to attach the positive exponent 3 over 2 to negative 81. So now let's take a look. So this is same thing as 1 over, well, bottom is the root. So here what we're going to get is square root of negative 81 to the third power. Now do you notice something? We got square root of a negative 81. Can we take a square root of a negative? Nope, we cannot, because if you square any number, it's always going to be positive. There's no way in heck that if you square a number, it's going to be negative. So in this case, we say that the answer is not going to be a real number. So I'll write it as not a real number. Pretty soon, we're going to be learning about this thing called the imaginary numbers. So don't think that not real number means, oh, it's a fake number. No, it means real versus imaginary. But anyways, we'll get there later on. So here, what I did was I just posted this chart in case you forgot about the basic properties of the exponents. So please memorize all of these properties, and maybe you can write it down on the note card or something. So let's take a look at example 5. Simplify x to the 1/5 whole thing divided by x to the 6/5. So again, please note this property, x to the m over x to the n. This is x to the m minus n. Okay, so I'm going to apply that property here. So this is same thing as x to the 1/5 minus 6/5. So that's same thing as x to the negative, what is that, 5/5? Which is same thing as x to the negative 1, but I never want to see a negative exponent as part of your answer, so always make it into a positive exponent by flipping it. So here you're going to have 1/x. So that's going to be the answer. Okay, part B, x to the 1/6 times x to the 4/3. So here what we need to do is you can go back and see all the properties, but what we need to do now is we need to add the exponents. So here you're going to have x to the 1/6 plus 4/3. All right, now what we need to do is we need to get the common denominator. So I think that will be 6. So you're going to have 1/6 plus, let me see. Here, in order to get 6, I need to multiply the top and the bottom by 2. So here, you're going to have 8/6, which gives us x to the 9/6. And just to reduce it a little bit, so this is going to be x to the, let me see, 3 goes into 9 3 times, and 3 goes into 6 twice. So it looks like we're going to have x to the 3/2, and we're not done yet because we need to convert this back into a radical. So again, bottom is the root, so what we're going to get is square root of x to the 3rd, or you can write this as square root of x to the 3rd. Means exactly the same thing. So, but I like the way this one looks a little bit better right now, so I'm just going to box that for the answer. Oh well, what the heck, let's just box both of them for the answer. Okay, now let's take a look at example 6, simplify. All right, so step number 1, what we need to recall this property, a times b to the n. This is a to the n times the b to the n. All right, so pretend our a is 27 and b is x to the 1/2. So our next step is going to be 27 to the 2/3 times x to the 1/2 to the 2/3. All right, now let's take it from here. So this is same thing as, well, bottom becomes the root. So in this case, what we're going to get is cube root of 27 to the 2nd power. All right, and then the next one, let me see, this guy right here. We need to recall this property. If you have a to the m to the n, you multiply. So this is a to the m times n. So we're going to apply that property to x to the 1/2 to the 2/3. So here what we're going to get is x to the 1/2 times 2/3. Now that means 2 is going to cancel. So what we get is, let me just work this step by step, cube root of 27 squared times x to the 1/3. Now let's try to simplify cube root of 27. So if you don't see it right away, break it down. 27, what goes in? 3 times 9, and then 3 times 3. So 27 is 3 to the 3rd power. So here what we're going to get is cube root of 3 to the 3rd to the 2nd power, multiplying here by the cube root of x to the 1st, which is just cube root of x. So let me just go over here now. So that's same thing as 3 squared multiplying here by cube root of x. So it looks like our answer is going to be 9 times cube root of x. So I'm just going to box this for the answer. Let's do another one. So we have part B. All right, so first thing first. What's in the parentheses, you cannot combine those two because our bases are different. First base is A, and then the second base is B. So we cannot add those two exponents, which is 2/3 and 1/2 together. However, if the bases are the same, so if you have something like a to the 2/3 times a to the 1/2, then yes, you can add those exponents together. But anyways, let's keep going with this. So this is same thing as, oops, what did I write 2 there for? Sorry. So this is same thing as a to the 2/3 to the 3/2 times b to the 1/2 times 3/2. So again, what I just did was I just applied this property. A times b to the n is a to the n times the b to the n, where this guy is a and pretend that guy is b. Okay, so now let's keep going. So next step is this. You need to multiply those exponents together. So here you're going to have a to the 2/3 times 3/2. And then here you're going to have times b to the 1/2 times 3/2. So now let's see what we get. So here you're going to have a to the, well, we're going to have a to the first multiplying here by b to the 3/4. So it looks like our answer is going to be a times, well, b to the 3/4, so bottom is the root, so we're going to have a 4th root of b to the 3rd, and that's going to be the answer. All right, now let's do example 7, simplify. Okay, so do not run away from that problem because it is not as bad as you think. As long as you take one step at a time, you got this. Okay, so first what I'm going to do is this. I'm going to combine the numerators together. So remember, if I have a to the m times a to the n, since bases are the same, we're going to have a to the m plus n. So that's the first step that I'm going to take. So here you're going to get x to the 3/4 plus negative 1/4. And I'm just going to leave the denominator alone for now. Okay, so then if I combine that, so we get x to the 3/4 minus 1/4 is 2/4. Whole thing over x to the negative 6/4. All right, so now what we're going to do is this. I guess we can simplify the exponents a little bit by dividing out by 2. So next step, let's just simplify a little bit. So this is equivalent to x to the 1/2. Whole thing divided by x to the negative 3/2. Okay, that looks a little bit cuter. Okay, so now next step is, what I'm going to do is, if you have a to the m over a to the n, this is a to the m minus n. So this is going to become x to the 1/2 minus, be careful, it's top exponent minus the bottom exponent, but the bottom exponent is negative 3/2. So what's going to happen is that this is going to be x to the 1/2 plus, oh sorry, that's a plus, 3/2. So this is going to give us x to the 4/2, which gives us x squared. All right, let's look at part B. So we got that expression going on. Now there are a few ways that you can do this, but first what I would do is, if you can simplify what's in the parentheses, do that first. So what I'm going to do is this. Let's combine all the x's together by using the properties of exponents, and then we're going to deal with the y's. So here, if I write this nicely, let me see. So this is same thing as 16. Now let's deal with the x's. So here you're going to have x to the top exponent minus the bottom exponent. Are you guys following? All right, and then let's deal with the y's. We're going to do the same thing. So here what we're going to get is y to the negative 5/6 top exponent minus the bottom exponent. All right, now whole thing to the 1/2 power. So now you're probably wondering, what the heck happened to the denominator? Well, denominator is going to be 1 because you brought the x to the negative 2/3 and y to the 1/6 upstairs, meaning to the numerator now. So pretend that the denominator now becomes 1. Now, what I'm going to do now is keep simplifying. So this is going to be 16 x to d. So we have, what do we got? 4/3 plus 2/3. All right, every step out. And then you're going to have y to d negative 5/6 plus, this is the same thing as negative, plus negative 1/6 to the 1/2. So let me see. So this is going to give us 16 x to d. What do we get? 6/3. And then y to the negative 6/6 to the 1/2. So almost done. So we got 16x to the second, and then y to the negative 1 to the 1/2 power. All right, now what I'm going to do is I'm going to distribute the outer exponent 1/2 to each term. Don't forget to distribute it to each term, meaning this is same thing as 16 to the 1/2, x squared to the 1/2, and then y to the negative 1 to the 1/2. So this is same thing as the square root of 16. And next value is going to be square root of x squared, so which I'm just going to leave it as x. And then y to the negative 1/2. So this is same thing as square root of 16 is 4, and then times x. Now I never want to see a negative exponent, so let's work on y to the negative 1/2. Do you see what's going to happen? You take the reciprocal of y, which will be 1 over y, and then you attach the positive exponent on the y. So here, this, by the way, this expression is exactly the same thing as 4x all over y to the 1/2. Because remember, 4x is same thing as 4x over 1, isn't it? So when you multiply two fractions together, you just multiply it straight across. So here, are we done? One more step. So we're going to have 4x whole thing over, well, y to the 1/2 is same thing as square root of y. So I'm just going to box that for the answer. All right, so let's just do this as a last example that we're going to do for this section. So pause the video and try part C to see if you can get it or not. You got this. Just take one step at a time. Now I'm going to pretend that you paused it and tried it. So first, let's combine all the x's together. Then we'll just deal with the y's next. Okay, so first step. This is same thing as 27. Now, x to the top exponent minus the bottom exponent. And then y to the 1/6 minus 5/6 to the 1/3. So this is same thing as 27 x to the 3/5, and then y to the, remember, 1/6 minus 5/6 becomes 1/6 plus 5/6, which will give us 6/6 to the 1/3. Okay, so now this is same thing as, well, 6/6 is just same thing as 1, so I don't want to skip any steps, so let me just write it like that. All right, next step, distribute that exponent. So we're going to have 27 to the 1/3, x to the 3/5 to the 1/3, and then y to the 1/3. Okay, so now we got cube root of 27, and here you're going to have x to the, well, you can cancel out the 3's from the denominator and the numerator, so here you're going to have 1/5, and then y to the 1/3. Okay, so if you combine this together, if you convert this into a radical, then here what we're going to get is, let me see, 27 was 3 times 3 times 3, so this portion here, it's going to become 3. I think we did that example earlier. And then 5th root of x multiplying here by the cube root of y. Now you cannot combine the 5th root and then cube root together. Alright, so this is going to be the answer. How did you guys do on this one? Okay, do not get discouraged if you got it wrong. Just catch your mistakes because that's the most important part. Oh, and one more thing, please don't do this. So I'm just gonna write it. This does not equal to 3 times 8th root of x times y. I've seen this done a few times by students, but you cannot combine the different roots together. So just keep it the way it was, which will be 3 times 5th root of x times cube root of y. Anyways, I'm gonna stop right here. I hope that you guys are kind of getting the hang of it. And again, if you have any questions, please let me know. And great job once again. I'll be talking to you soon.